Hey guys, we're going to learn about factoring this week. I'm going to try to do this as quickly as possible. There's a million videos on the internet that you can look up as well to help you understand this. Um, just type in, go to YouTube and type in factoring or factoring polynomials and or factoring quadratics, and it will give you a load of information. There's more than I'm going to be able to cover in a 15-minute. Normally, we would spend an entire week, maybe even 2 weeks, doing this. We are going to talk about this again next week about factoring, so that hopefully, because this is a very important part of Algebra 1 that you need to have for geometry in Algebra 2. So I want to make sure that we go over it as in-depth as possible, but also as quickly as possible so that we don't inundate you with a bunch of unnecessary work. Okay, so when I have a quadratic, which means I have an x squared in my equation, the only way that I can solve that equation is to factor. Normally, if I have x plus 3 equals something, I can just subtract 3 from both sides and figure it out. If I have an x squared, I can't just subtract and multiply and divide and all those things away. I have to do something that's called factoring, which means I have to break it down into those types of linear expressions. So I have to turn an x squared function, an x squared term, into two x terms. I'll show you what that looks like here in a second. Let's do an easy one first. Let's say I have x squared plus 6x plus 8. Okay? Now, basically the rules of factoring is that I want to break this down. Okay? I can't solve this the way it is. I don't know how to undo x squareds when I have an x and a number in there. If it was just x squared equals a number, I could take a square root, which we've talked about, and I could solve it that way. But this little x right here throws a wrench in things, because if I take the square root of all this, then I have the square root of x, then I have to square it to get rid of the square root, and then I'm right back to where I was before. So this is why I have to factor things like this, because if I just take the square root, then I've done nothing. I just keep going in circles of squaring and square rooting and squaring and square rooting, and I never actually get the answer. Okay, so factoring is basically breaking this thing down into two parts that are multiplied together. Okay, and the way we do that, I call this the Xbox method. It's easy to remember because everybody knows what an Xbox is. And basically, I call it the Xbox method is because at the beginning, I draw an X and I draw a box. Okay, so to solve this, the Xbox method, I draw an X and I draw a box. Now, the box you've seen before. When we were multiplying polynomials, we did the little box where we would do like x plus 2 and x plus 3, and then we multiplied x times x to get x squared, and 2 times x to get 2x, and all that kind of stuff, and then we added the like terms. Basically, with factoring, we're going to undo that, okay? And here's how we're going to do that. In the x, the first part, I use the numbers, these last two terms, to figure out what's going to be in my box. Okay, so I write the last number in my polynomial. Okay, so whatever this number is without an x, just the constant, right here in the top. And then I write the coefficient of the middle term. So whatever number is in front of my x, or my middle term, in the bottom of my x. Okay, now what we're doing in this x is we're trying to figure out two numbers right here that have these two relationships. The two relationships are what two numbers multiply to give me 8 and add together to give me 6. So think about it. What are the only possibilities of combinations of numbers, or what are the multiples or the factors of 8? Well, 1 times 8 is 8, so it could be 1 and 8, but is there any way that I could add 1 plus 8 to give me 6? No. But there's another combination. What's another two numbers that multiply together that give me 8? 2 and 4. And what is 2 plus 4? 6. So the two numbers that multiply together to give me 8, but add together to give me 6 are 2 and 4. Okay, so now I use this information to fill out my box. I'm gonna put numbers in my box. The top left corner is always my first term. Okay, so whatever was here, I put that in my top left box. And whatever my last number is, I put that in the bottom right box. Okay, now I use these two numbers as the coefficients in my other two boxes, and it doesn't matter which box I put them in, it's not going to change the value. Now, the tricky part is I add whatever this is to it. So in this box, since it's 6x, I'm going to write 2x, and then in the top right box, I'm going to write 4x. So now I can fill out the outside of my box based on this information. So what two values can I multiply together to give me x squared? Well, there's only two things. X times x gives me x squared. Okay, so the first term of both of my factors is x. Okay, now that I have this, what number am I going to put here above this that's going to multiply times x to give me 4x? Well, that's easy. That's 4, because 4 times x gives me 4x, and it was positive 4, because it's positive 4x. And then down here, what number times this x would give me 2x? Well, 2 times x gives me 2x. So these right here are my two factors, my two answers. And the way I write that, because factors are multipliers, I write that as x plus 4 times x plus 2. This is the factored form of this. If I multiplied all of this stuff out, if I did x times x and then x times 2 and then 4 times x and 4 times 2 and added all my common terms together, it would give me x squared plus 6x plus 8. So that's how we factor. Okay, we do the Xbox method. Okay, let's do another one. I'll leave that one on the board. Let's say I have x squared plus 22x plus 121. Okay, again, I'm going to use my Xbox method. So I'm going to draw my x down here, and I'm going to draw it a little bit bigger so that you can see it a little better. And my box right there. Now, what numbers go in my x? The top number is my last number, so it's 121. Bottom number is the coefficient right here. So again, I'm going to figure out what numbers multiply together to give me 121 and add together to give me 22. Now 121 is a pretty big number, but it's a number we should remember because it's one of those perfect squares. And what squared gives me 121? It'd be 11. And what's 11 plus 11? It'd be 22. So, because 11 times 11 is 121 and 11 plus 11 is 22, that ends up being the numbers for my x. So now I fill out my box. My top left is this first term, is x squared. My bottom right is this last number, 121. Now in these two, I put these two numbers along with whatever is in my middle, whatever variable is in my middle. So I'm going to do 11x here and 11x here. So again, what two values multiply to give me x squared? That would have to be x times x gives me x squared. Okay, and then what number times x gives me 11x? Obviously, it's 11. Anytime this is just x, whatever this number is going to be that number. Now, the signs matter, and we'll talk about that here in a second. So this is going to be plus 11, and this is also going to be plus 11. So the answer, the factors of x squared plus 22x plus 121 is x plus 11 times x plus 11, which anytime I have the same thing multiplied by itself, I can rewrite that x plus 11 squared. So this would be the factored form of this. Now, let's talk about a little different dynamic. What happens if I have x squared plus x minus 12? This one looks a little bit different because it's really hard to add a number, two multiples that multiply by to give me 12, to add to give me 1. Does that happen? Well, the change is right here. Again, we're multiplying two numbers. So what's the only way we can multiply two numbers to get a negative answer? Well, that means one of them is going to be positive and one of them is going to be negative, because a positive times a negative is a negative, right? But when I add a positive and a negative, I'm actually subtracting. Okay, so let's draw out my X box. Okay, and again, I don't change the process, but I have negative 12 is my top number and positive 1 is my bottom number. We don't change anything. This is still the two numbers that multiply together to give me negative 12, but they add together to give me positive 1. So what are the possibilities of numbers that multiply together to give me 12? Well, we've got 1 and 12, 2 and 6, and 3 and 4. Those are all the pairs of factors of 12, right? But which pair of those, if I subtracted them from each other, are going to give me an answer of 1? Well, 12 minus 1 is 11, so that's not going to work. 6 minus 2 is 4, so that's not going to work. But what's 4 minus 3? It's 1. So that's my pair. I'm going to have 4 and I'm going to have 3. But remember, I have to have two numbers that multiply to give me negative 12. So that means one of these numbers has to be negative. But which one is it? Well, here's the rule. Whatever sign this middle term is, that's the sign of the bigger number when I have a negative value in the top of my x. Okay, so since this is positive 1, that means my bigger number is going to be positive. Well, which one is bigger, 4 or 3? 4 is bigger. So that means 4 has to be positive, which means the 3 is the one that is going to be negative. Now my x works, because 4 times negative 3 is negative 12, and 4 minus 3 is 1. Okay, so it says we're adding, but whenever we have a negative number in here, we're actually adding a negative number, which is the same as subtracting. Okay, so that's how that works. Well, anytime there's a negative number on my last number, this is going to be the case. The number is going to be smaller down here when I'm adding, because we're subtracting the two middle terms instead of adding them. Okay, nothing changes about my box. I still write my first term from up here in the top left, my last term down here in the bottom right. I still add these numbers with this term, so I have 4x and negative 3x. But now check it out. Again, what times what gives me x squared? That's going to be x times x. And then, what times x gives me 4x? That's going to be plus 4. But what times x gives me negative 3x? That's going to be a negative 3. So this quadratic, sorry, it's been a long morning. This quadratic factored is x plus 4 times x minus 3. And those are the factors. Now, what are we going to use this for? What could possibly be the function of this? Well, we're actually going to use this to solve these equations. Let's take this example right here. Okay, let's say I have x squared plus x minus 12 equals 0. So what's the difference here? Up here I just had a term. I had a quadratic term. Here I have an equation because I have an equal sign. It equals something. So with this, I want to find the two values, because this number right here, the exponent, tells me how many possible answers I could have to this equation. So I want to find the two possible answers that I can plug in for x that's going to make this equation true. The answer is right here. I've already factored this, so we're not going to go through that process. But what we do is we factor it to get those two factors. So I'm going to rewrite this. X plus 4 times x minus 3 equals 0. Now, rule number one of these solving these equations by factoring. The first step is always the equation has to equal 0 before you start factoring. Okay, if you don't move everything over with the x's, you're going to get all kinds of messed up. Okay, and there are some problems on your homework today where I think number 9, the first one where you have to solve, is exactly one of those. It says x squared plus 19x equals negative 84. Okay, negative 84 is not 0, so we have to add 84 to both sides to get it over there so it's equal to 0. And then I can figure out what two numbers multiply together to give me 84, add together to give me 19, and then I can solve it this way. Okay, now, once we get here, this is very similar. Remember back when we were solving absolute value problems, where we would have the two answers because we had to take into consideration the positive and the negative absolute value, give me the possible answers. Well, with quadratics, I do the same thing. I'm going to draw the same railroad tracks that I drew with the absolute value functions. Okay, but now all I'm going to do is I'm going to take this one, x plus 4, and make it equal to 0. And then I'm going to do x minus 3 equals 0. Now, why am I doing that? Well, this is the basic property of multiplication. If this thing equals 0, what is the whole equation? Because we're multiplying, it doesn't matter what this is. This ends up making everything 0 because 0 times anything gives me 0. And the same thing, if this ends up being 0, 0 times whatever this ends up being is still going to be 0. So these are my two possible answers, whatever makes each of these equal to 0. And these are simple. We subtract 4 from both sides, and x equals negative 4. We add 3 to both sides, and x equals 3. So the two answers that make this equation true are negative 4 and positive 3. Now let's check it. If I plug in, this is supposed to be 12. If I plug in 3 right here, 3 squared is 9. 9 plus 3 minus 12 should equal 0. Well, 9 plus 3 is 12. 12 minus 12 equals 0. So it works. Same thing here. Negative 4 squared is positive 16. Positive 16 minus 4 is 12. And 12 minus 12 is 0. So both negative 4 and 3, when I plug them in for x, makes this true. This is why this is important. This is the only way and the easiest way, not the only way, it's the easiest way to solve these quadratic equations. And that's the first thing that you're going to do in Algebra 2 in 2 years. It's also going to be used a whole lot next year in geometry when you're finding the area of quadrilaterals and the area of triangles. You're going to have to factor those things in order to solve them. Okay? So that's basically how factoring goes. I will be having a Google Hangout at 1 o'clock on Wednesday to answer any of your questions about factoring and walk you through some stuff. So that's how it is. Your homework is going to be on Oasis. You're not doing questions 1 and 2, so just do problems 3 through, and the instructions will be on Oasis again. So hope you guys are having a great week. Hope that you get out a little bit over the as things start opening up and get some fresh air and leave your house a little bit. Love you guys. Have a great week.